Mrs. M. Priyadarshini, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for Corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, OOAD, and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, OOAD, databases, enterprise technologies, and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science part 19. So, in this session, we are going to see about UDP, datagram packets, about datagram sockets, and then a small demo program, a client server program which is going to use UDP for communicating between them. So, first we will see about UDP. So, in your previous session, we have seen that UDP is nothing but user datagram protocol. So, we have also seen that how it is different from that of the TCP/IP, that is your transmission control protocol, and then your internet protocol. So, that TCP/IP is a connection oriented protocol. It means that whenever a client sends a information to the server, a physical connection should be established between the client as well as the server. So, whenever a host sends an information to another host, that host to which I send the information should be available at the point when I send the particular message. Whereas in case of UDP, whenever I try to send a message, it is not necessary that your acknowledgement is received. It means that I send the information, I never get an acknowledgement from the receiver, and in some cases that it is also possible that the data may be lost during the transit. So, it is connectionless protocol as well as it is unreliable. So, whenever we send information through TCP, it will be reliable because I always get the acknowledgement, whereas in case of UDP, we do not get any acknowledgement. So, it is not a reliable protocol. But whereas if you want to send more number of packets, we normally choose user datagram protocol. So, here we have two classes, datagram packet and datagram socket. So, the datagram packet and datagram socket classes are available in java.netpack. So, this implements an UDP communication. Many firewalls and routers are configured not to allow UDP packets. So, the java.net package consists of many classes such as socket, server socket, INET address, URL connection, which we have seen in the previous session. Whereas here, in order to implement UDP, we have datagram packets as well as datagram socket class. So, these two classes are used in order to implement your UDP communication. And we have also firewalls and routers. These firewalls and routers normally block the UDP. In that case, we need to unblock it and then we have to execute our programs. So, UDP protocol provides a mode of network communication whereby application sends packets of data called datagrams to one another. A datagram is an independent self-contained message sent over the network whose arrival time and the content are not guaranteed. So, here we have a packet of data. So, this packet is nothing but an instance of your datagram packet. So, I need to create a datagram packet and then send it across the network through the datagram socket. So, here our mode of communication happens with help of the datagram packets, and your datagram is an independent self-contained message which doesn't has information about arrival time and content, and these are not guaranteed. So, I don't know when that particular packet arrives and what is the arrival time of that particular packet, and also about the content. So, this is, as already told, this is not a reliable protocol, and so we never have any information regarding the message that is received or message that is sent. It is not stored anywhere. This datagram packet class represents a datagram packet which contains data either to be sent or received through the datagram socket. It holds additional information such as its source or destination host. So, you can see that the same datagram packet could be used for sending as well as for receiving. So, we have only one socket here, whereas in your TCP IP we have socket as well as we have server socket. We have two streams, and through those streams only we try to access the data. Whereas here we have socket. In this socket we could use send and receive methods in order to send and receive our datagram packets. And from that particular datagram packet, we will be able to identify which is the host and destination which has sent that datagram packet, as well as the host which is going to receive, that is your destination which is going to receive that particular datagram packet. So, these are constructors of datagram packet class. Datagram packets has informations such as byte array and length. Constructs a new datagram packet object to receive data up to the length of a particular bytes. Datagram packet, I have a byte array, length, INET address and the port number. So, this constructs a new datagram packet object to send data to the particular port of the particular address host. So, here byte array is given as input. So, this byte array is the contents that your datagram packet is going to hold, and we have specified the length also in the constructor. Sometimes we also specify the INET address in which your datagram packet is to be sent. So, you can see we have few methods in the datagram packets in order to know information, such as get address. So, returns the IP address of the machine to which the datagram is being sent to, and off from which the datagram was received. So, we have already seen that send and receive both are done on the same datagram packets. So, we can send as well as receive, and the IP address of the sender or the receiver could be accessed from this method. Get data method returns the data received or the data to be sent. So, this gets the byte array data that is available in the datagram packet. So, there is a method called get length which returns the length of the data to be sent or length of the data received. And get port method returns the port number on the remote host to which the datagram is being sent to or from which the datagram was received. So, your get length will give you the length of the particular datagram packet. We always never send the entire datagram packet. So, the maximum normally byte array holds 256 bytes. So, we never always send 256 bytes, and there will be particular length to which only you send the data. So, that could be accessed, and then get port will make you know the port number to which it has been destined to, that is the destination port number to which this particular datagram packet will be sent to. So, next we will have a look on datagram socket class. So, this datagram socket class represents a socket for sending and receiving datagram packets. So, in our TCP IP, as I already told you, we have socket and an input stream and output stream associated to a socket. And the other end, in the server end, we have a server socket which is going to receive this socket, and I'll accept the particular connectivity. On accepting the particular connectivity, only a connection is being established between your client and the server. Whereas in case of UDP, it is connectionless protocol, and I send the data using my send message. At the other end, I will be able to receive the particular datagram packets that is being sent. So, in this case, there is no connection that is established as such in your connection oriented protocol. So, in that case, in the case of my TCP IP, I need to worry about whether the server is live at that point of time, and then once server is live, I can also gather few information from the data that is being sent from the client and send the information back to the client. Similarly, in your UDP also, whenever I send some information from my UDP datagram packet that has been received, I can even gather some information and then connect to my client from where my user datagram packet has been received. So, here this socket class is the one which is used to send and receive your datagram packets. Each packet sent or received on datagram socket is individually addressed and routed. So, each and every datagram packet I send is a different instance. So, I cannot send a stream of datagram packets. So, it means that each and every of the packet is separately identified, uniquely identified. So, for example, I first create a datagram packet 1 and then I create a datagram packet 2 and I keep on sending each and every datagram packet. So, it is not a continuous stream like as that in your TCP IP. So, in case of TCP IP, it is a continuous stream. Once the connectivity is established, the data you can keep on writing your data as well as you can keep on reading your data, whereas here each and every packets are sent and at the other end the receiver will receive that. Even there are certain cases where few of your packets may get lost. So, for example, I have sent first datagram packet and then I am trying to send a second datagram packet. So, meanwhile, I try to send a third datagram packet, my datagram packet 2 would not have been received at the other end. So, there is a possibility that even before your datagram packet 2, your datagram packet 3 reaches the server. So, in that case, they may not be in a particular order. So, it means that these are sent as discrete datagram packets, whereas in case of your TCP, it is a continuous stream of data. So, multiple packets sent from one machine to another may be routed differently and may arrive in any order. So, this is what. So, you can see that in a network, you cannot say that the packets, if I have n number of packets, all the n number of packets will not pass on through the same route. So, we have various mechanisms in order to route your packets to your destination. So, there will be many routes. So, while I route it, one packet may follow one route and another packet or other set of packets may follow any other route. So, in that cases, I cannot confirm that all the packets are sent through the same route and they receive in the same order. So, sometimes maybe due to some network problems, we may not be able to receive few packets and we may receive them at the end. So, datagram sockets constructs a datagram socket and binds it to any available port on the local host machine. So, whenever I call this constructor datagram socket, so it means that I am trying to create a datagram socket to any available port, currently available port on the system. I have not specified any particular port number in which this particular datagram socket will be connected to. Next, we have another constructor with datagram socket and then the port number. It constructs a datagram sockets and binds to the specified port on the local host machine. So, in my current machine where I am, and then I give a particular port number in which my datagram socket need to be created. So, through this socket we send and receive the information. In your previous sessions, we have also seen that port is a hardware component. For this port, we normally assign a socket. Socket is a software component. So, here we have another constructor datagram socket in which I pass an integer, that is my port number, and then I pass my INET address. So, INET address class, we have seen what is INET address class. This INET address class is used to resolve the IP address of your system or your host name. So, here a datagram socket is created which is bound to specified local address. So, a datagram socket on that particular address with that particular port number is created. So, next we will have a look on what are all the methods we have in datagram sockets. So, close. So, whenever I open a socket, I can keep on sending many packets, that we know. So, if at all I am trying to stop sending my packets, so then I can use close and then I can close my datagram socket. So, next method is get local address. So, get local address to which the socket is bound. So, this get local address, I already told you there are 3 constructors for creating your datagram sockets. One in which you never specify the port number, the second in which you specify the port number, and third constructor we specify the address as well as the port number. So, now it means that the socket is binded to a particular port number. So, in that case, whenever I call this get local address method, this method will return the local address to which your socket is bound. And then we can, I also told you that port for a particular INET address, then that particular port could also be received using a get local port method. So, this returns the port number on the local host to which the socket is bound. So, now we will have a short break and then we will proceed with how to create an client server communication using an UDP socket. So now we can continue with your UDP sockets as well as how to establish a client server connectivity using UDP. So now we were looking at what all the various methods we have in datagram sockets. We have seen about close, and then we have seen about local address, and then how to get the local port. So on receiving all this information, we also have few other methods. One is get your socket timeout. So even you have method to set the socket timeout. So this get method is used to retrieve setting for S, that is your socket timeout. So till when your socket need to be available. So already we know that TCP is a connection oriented, so it has to be continuously available, whereas here you can set up a time till which your socket need to be connected to. So next is receive method. So receive method accepts datagram packet as the parameter. So this receives a datagram packet from the socket. Next is send method, which is going to send a datagram packet from this socket. So before we call this receive method and before we call the send method, we ensure that the datagram packet is available. So if at all I am calling my receive method, it means that from your client end you have received a datagram packet. If you are trying to send a datagram packet, so in that case we should ensure that a datagram packet has been created and we are trying to send the already created datagram packets. So here we have a demo program. So you can see we are trying to import the IO package and we are trying to import the net package. So we have a UDP client program. So this is your main method. So here I am specifying it throws exception. So we have many exceptions such as unknown host exception, IO exception to be raised while I execute my network program. So here you can see inet address, inet address dot get localhost. It means that you are trying to get your inet address object corresponding to your local host. So this program could be used to create a UDP client server communication from your current system to your current system. So next is datagram. I am creating an object of datagram socket. Datagram socket is equal to new datagram socket. So now I know what is my inet address and then I know my datagram socket, which is used in order to send the information. So from your client side we are going to send the datagram packets. So here you can see that I have declared a datagram packet and then we have byte array. So we are constructing a byte array. As I already told you, the maximum number of bytes normally given for your byte array which your datagram packets can hold is 256. So now I have a text here, that is a string. So this string is converted into bytes. So there is a method called getBytes. So I am calling the method getBytes of the string. So this will return a byte array. So now B1 will be filled with the byte representation of this particular string. So now I have my datagram packet, new datagram packet. I am specifying the particular byte array and then the length of the byte array, the address. So here ADDR is now currently pointing to the inet address object of your current system and then the port number to which I am going to send this particular datagram packet, and then I am calling the send method of my datagram packet, datagram socket. So now I am sending a particular datagram packet. So I have constructed a datagram packet called SEN and then I am passing this as the parameter to my datagram socket. So here we have a UDP server program, where in this server program we have a datagram socket and then we have a datagram packet. So here in your datagram socket class, as already told, you have send method as well as receive method. In your client program we have used send and here we will use receive in order to receive the datagram packet. So here I have declared a datagram packet object. So here we have a byte array, same as that of your client program. I am constructing a byte array. Now I call a new datagram packet. So this is constructor which has a length. So here my B1 will have the entire 256 because Here I don't have any data as such in my datagram packet. So here I have a byte array. That byte array is assigned to the datagram packet. So, and then I have the length of the byte array being specified. So, here in this REC, I don't have any data. So, I am constructing a blank datagram packet. And then I call the receive method of my datagram socket. So, this REC which is passed as the parameter, the datagram packet which is passed as the parameter to your receive method will be filled with the particular datagram packet that is obtained from your client program. So, from your client end through sent, I would have sent a datagram packet, and here when I call this receive method, so your datagram packet REC will be filled with whatever the contents that is being received from the client end, the datagram packet that is received from the client end. So, now my REC datagram packet will have the contents of a byte array. So, you can see here I have a string data is equal to new string. I am constructing a string and then I am calling get data method of my REC. So, get data method of my datagram packet will give the data in form of byte array. So, this byte array will be passed as a parameter to your constructor of the string, and then I am trying to print the client data, and then here in the string I call a trim method. Here you have noticed that we have constructed a byte array of 256 bytes, and then if at all there are unused bytes, you can trim and show that to the user. So, here first what we need to run this client server program. So, in case of your TCP, we have a server program which acts as the listener. So, we have a server socket which will act as the listener, and that will be waiting to accept the socket that is being sent from the client end. Here, in case of your UDP client server program, we have a UDP client and then we have a UDP server program. So, in your client program, we are trying to construct a datagram packet with the data which we need to send, and we send the datagram packet. In your server side, we call the receive method and receive the datagram packet that has been sent from the client side. So, here the information that is passed will be in form of bytes. So, again in your client we have mentioned to which server we need to send the information, as well as we have specified which port number that need to be sent to. And here first what we need to do is we have two programs. So, these two programs here will be available in the same system, because I have used the localhost get localhost method in order to resolve my IP address. So, in order to resolve my IP address, since I have used the get localhost, so I will get the IP address and hostname of my particular system, the current system in which I am running my program. So, here the client and then the server both are running in the same system. So, you can see here first I am trying to compile my UDP client program which is available in a folder called UGC. So, again we have a server program also. So, I am compiling my server program also. So, here client is one command window and your server is another command window. So, we have two command windows. In one of my command window I have compiled my client program, and the other command window I have compiled my server program. So, next you can see here I have invoked the server. So, here we have not specified any message as we have done in the TCP program, just to we are waiting, we have called the receive method. So, this server will wait for a datagram to be arrived at that particular port number in which the datagram socket has been created. So, we have created a datagram socket which is connected to a particular, bound to a particular port number. So, now that will be waiting for some datagram packets to be sent by some client. So, next we are trying to run the UDP client program. So, in your UDP client program, we have seen that we have a string called client is here, and then we have converted that into bytes, and that byte array is being created as a datagram packet, and then it has been sent through our datagram socket. So, now that execution will send the message called client is here to the server. So, now this message should be received at the other end, that is your server end. So now you can see here message from client is here. So client is here is the message that is sent from your UDP client. So in this particular program, just from my client I have sent some information, and the other end I have received the information. I don't have any information with respect to the I have not received any information, I have not taken any information about the client, and I never send anything back to the client. So just from here I have sent the message. So next we have made some few changes in the program, and we have made that I send some information from here to the server, and back the server is trying to send some information to the client from the information that is gathered from a datagram packet. So already we have seen that in datagram packet I cannot know what the time of the arrival which guarantees that this is being received at any point of time and all. So whereas, but we could identify from which system, from which host your information has come, and from which port number the information has come. So the same information, there we have created a byte array to send the information in your client side. Now in the client side itself we try to introduce a new datagram packet, and then I have created a byte array, and then I am trying to receive. So first I will send the information from the client, and then I call the receive method. So after sending the information to the server, my client program will wait for a datagram packet from my server. So here I call receive.getData. So this is the same piece of code which we have written at the server side. So it means that now my client could also act as a server. So this is not in the case of your TCP/IP. So here after I send the information as a client, then I am waiting for some input from my server. So at the server side we have included a datagram packet called send. So from normally in your UDP server we have a receive datagram packet. So here we introduce a new send packet, where after receiving the message from the client I am trying to send back some other information to the client. So here you can see inet address, I am getting the client address from my REC. So REC is the packet that has been received at your server side. So already we have seen in the previous program that UDP server receive REC is nothing but the packet that is being received at the server side. From that I am getting the address. From that I am receiving the port number. So I know the address and port number of the client which has sent the particular datagram packet. So then I am trying to create a byte array. Server is sending a message .getBytes. I am converting that into byte, and then I am creating a new datagram packet with B2, that is your byte array, and then your client address which you have resolved and which you have found out from the datagram packet, and then the port number, and then I am trying to send the information to the client. So whenever I send this, so this will be sent to the client address with the particular port number from where I have received my datagram packet. So you can see here I am having the client, and then here you can see that once I run the client, from here a message called client is here will be sent to your server. So message from the client is here. After receiving this, your server will send an information back to the client. So now it is received at the client end. So as a summary, in today's session we have seen about UDP, user datagram protocol, about datagram packets, datagram sockets, and then a demo program, and then enhancement of the demo program which could act as well as the client as well as the server. So from this session you will be able to answer questions such as what is the datagram packet, what is significance of send and receive method in datagram socket, how to run a UDP client server program, and so on. After this session we are going to see about your multicasting. So you know what is the difference between unicasting and multicasting. This UDP is a unicasting as for now. So we also have multicasting. So which we could continue with your future sessions. And thank you.